Yes. Okay, so today we will discuss about graphical analysis of kinematics. Today, inshallah, we will be done with this chapter, and then we will talk about some parts paper questions. So, graphical analysis is one of the most important technique in our kinematical questions. There are two aspects of solving the kinematics problem. One of them is graphs, right? And second technique is actually the equations of motion, right? In your A levels you have to deal with these as well. Equations of motion, usually they are named as SUVAT. Okay, maybe someone have talked about these equations with you. SUVAT, distance, initial speed, final speed, acceleration, and time. But this is not actually part of our syllabus. In our syllabus, only one equation is only two equations are used. One of them is S is equals to VT, which is basically the equation for your general or uniform speed or constant speed. And second one, A is equals to V minus U divided by T. So these are two equations which are usually used. So what I was talking about, that actually graphs and these equations are the tools to handle kinematics, right? They are tools to handle kinematics, right? So let's talk about the graphical analysis. First of all, we have to talk about the distance time graph. Before that, I want to discuss one thing, that is that what a graph tells us about. Okay, so when I talk about the graph, actually graph is a relation between two physical quantities, right? Are you sure about that? It is
Yes.
a relation between two physical quantities. So if I say that those two physical quantities in kinematics are, they can be any physical quantities, but in kinematics we will have the following one. What would be those in kinematics? In kinematics,
Fine.
first it can be your distance, right? Then it can be your displacement, then it can be your speed, then it can be your velocity, okay, and then it can be your acceleration, or you can say that can be deceleration. So all these are the physical quantities. Speed, then fourth one is velocity, and then fifth one is your acceleration, okay, and sixth one is deceleration. So these are six physical quantities which all change with respect to time. Okay, this is very important to know, that what is the variable by which we have to figure out the change. So they all change with respect to time. Is this clear to all of you? It means distance
Yes.
varies with time, displacement varies with time, the speed, velocity, acceleration, and time. So this tells me that we can discuss about distance time graph. We can talk about displacement time graph. We can talk about speed time graph. We can talk about velocity time graph. We can talk about acceleration time graph. Then we can time talk about and deceleration and time graph. So these six types of graphs can be discussed in our syllabus. So you people can take a screenshot of that. If I will try my best to send you this document as well, but I don't know, maybe it is open in any other document. So remember this thing. This was what I was talking about, the graphs. Is it clear, this slide?
Yes, sir.
Okay, then the next thing to be discussed for the graphs is that whenever we are talking about the graphs gives two types of calculations, or I can say that calculations on the basis of the graphs. Calculations from graph. So when we have graphs and we are going to calculate, or we are we have some calculations from those graphs. There are two types of calculations. Calculation number one is actually the calculation of its gradient, and second calculation is the calculation of its area. So first we can calculate the gradient of the graph. This is calculation number one. Whatever the graph do you have, you can calculate gradient of the graph. And second thing, what you can calculate from your graph, that is area of the graph. Okay, these are two calculations which can be performed from graph. Gradient of graph. So it means that I would tell you that how the gradients are generally taken. So are you sure about how the gradient is being taken? Gradient is your y2 minus y1 divided by x2 minus x1. It is how to calculate it. Or simply said, it is actually rise over run. This is another method for the graph. For another technique to find out the gradient. Okay, and when I talk about the gradient in further detail, it is actually gradient is the steepness of the graph. Do you understand steepness?
Yes.
Yes, sir.
Yes, steepness of graph. Okay, for example, I can have different type of you know behaviors from the graph. Let's say, let's start on this slide. That if I have, this is any physical quantity y with respect to x. I don't name it. It is generally a gradient graph, right? I will tell you about what type of gradients can be there in physics or maths as well, because gradient is also the part of, or also a technique from the math. So these are some sort of graphs which are generally asked from the from graph from gradient. First this one, then this one, then this one, then this one. Okay. Now these four are main parts. I can show you other as well. What is the gradient of the graph over here? Zero. Okay. Remember this thing. In graph number one, your gradient is zero because there is no rise at all. Are you getting it? Because no rise is there. So whenever I will talk about that, is there any gradient? So if there is a straight line parallel to the x-axis, you will say no, the gradient is zero. Am I right?
Yes, sir.
Okay.
Yes, sir.
Then in graph number two, I would like to say that there are two types of. Uh, I will draw two lines over here. One, this one, and the next one is blue one. So here in two, let's say it is uh, this blue one is 2a and this red one is 2b. Okay, so 2a is constant positive gradient. What is this 2a? 2a is its gradient is positive and constant. Remember this thing. And for 2b, gradient is constant but negative. Is this clear to all?
Yes, sir.
Yes, sir.
Okay. Then in third half or in third graph, what do you suggest? Is this gradient increasing or decreasing in graph 3?
Increasing.
Yes,
Increase.
it's gradient increasing. You can say this graph is basically of increasing gradient. Simply I can write that it is of increasing gradient. Okay, so you have to remember these behaviors, and this graph is having decreasing gradient. Okay,
Yes, sir.
decreasing gradient. So when we have these gradients in our discussion, then it would be very easy for us that whether gradient is increasing, gradient is decreasing, or what else. Okay, is it clear to both of you?
Yes, sir.
Yes,
Okay.
sir.
Now let's talk about another segment of this, that how to calculate area. Wait. I have to address another thing. As I was talking about the gradient, so gradient of distance time graph. If you have distance and time graph, that gives you speed. You have to memorize these to somehow, then it would be quite easy for you to understand or to solve the questions. The right gradient of distance time graph equals to speed. Okay. Secondly, you have to notice or you have to note down that gradient of displacement time graph, if there would be mention, otherwise in your syllabus displacement time graphs are very rare. Most of the graphs are distance time graphs. Displacement time graphs, that gives you
Velocity.
velocity. Very good. Then third, you should know that gradient of speed time graph, gradient of velocity time graph, both gives you acceleration. Okay, they both give us
Acceleration.
acceleration. So that's it. We have to now these 4 points related to the gradients, because nothing, no gradient of acceleration time graph is being asked to us. So is it clear?
Yes, sir.
Okay, now let's
Yes,
talk
sir.
about another aspect, the last one, that was how the area of the graphs are being calculated. Area, area of the graph is basically all portion below or above the graph. So it is basically the region between line of graph, line of graph, and time axis. Remember this thing. This is very important explanation, that where we have to take the graph or where we have to take the area. So this is the region between line of graph or curve of graph and time axis. Wherever the time axis, usually x-axis is the time axis and y-axis is the distance, displacement, or whatever. So we have two or three types of equations which can be used for the calculations of area. If your graph is, oh yes, one more thing, that area of only velocity time graph is calculated. Remember this thing. Okay, not distance time graph. Area of only velocity or speed time graph is taken. Only speed time or, yeah, and velocity time is taken. Velocity time graph is calculated. Okay, so I'm going to refine all those things for you, that you have no need to worry about others. Speed time and velocity time, they would give you area, right? So area of speed time gives us distance covered by the body. Okay, and area of velocity time graph gives you displacement. Is it clear to both of you?
Yes, sir.
Yes, sir.
Okay, good. Now, the last thing before coming back to the graph, that is how to calculate the area. So if you have this type of graph, that here it is speed and here it is time, and you are having a straight line at any position parallel to x-axis, then its area is basically area under this graph. This is its area, and you can say, rather drawing this way, I can say that this is the area, right? Its area is length times height, or length times width. It means its area is time into height is what? Speed. Am I right? So its area is base times height. You can say our length times width. So as I told you, area is distance, length is your time, and width is your v. So do you remember that equation what I have written at the start of the lesson, that distance is equals to s is equals to vt? Actually we get this equation from this area. So if we have this area, so we have to consider that the area is equals to length time width. If it is a rectangular graph, then we can say that its area is length time width. Okay, is it clear?
Yes, sir.
Yes, sir.
Okay, then if I have um, another type of graph, that is a constant speed. Sorry, that was the constant speed. Sorry, I have to mention that the constant speed graph, it is a constant speed or velocity graph. Now if I have a uniform acceleration graph, which graph? Uniform acceleration graph. Uniform acceleration graph. Uniform acceleration mean, I will explain you later on, but here just I'm going to show that this is increasing velocity. So in increasing velocity graph, you must have a triangular portion below the graph, like, okay,
Okay, sir.
like this. And this is actually, it appears just like a triangle. So we can say, if this is its base, this is its height, right? So I can say that its area is equals to 1 by 2 base times height. So as I told you, area is distance, so it gives you an equation 1 by 2. What is base? Base is basically its time. And what is height? Height is basically change in velocity,
Velocity.
right? So it is v minus u. Remember this. Why? Because initially its initial speed is 0 over here. That's why I have written it u, and here its velocity is v. So its initial speed, let me write it, change in velocity. Change in velocity. So you can say that it is s is equals to 1 by 2 v minus u. So it is another form of learning that you can have the distance by this method as well. Okay, is it clear to you?
Yes, sir.
Generally you have to remember this thing. Don't get worried about the other concepts. This is the key concept for you: base times height. Now this was the graph when body has a uniform acceleration and starts from rest, and starts from rest. Now if there is a uniform acceleration but body does not start from rest, for uniform acceleration but not starting from rest, then you will have a different graph. Uniform acceleration but not starting from rest. Okay, starting from rest, then it means your u is not equal to 0. When initial velocity is not equal to 0, your graph will not pass through origin. Am I right? Do you agree?
Yes.
Okay, so it is your v and t graph. So now I'm saying that the body is not starting from 0. This is that type of graph. So this graph tells you that here the body has initial speed u, and here the body has final speed v, this way. Okay, this is its final speed v. So here is the time t. So I can say that if I check this one out, isn't it a trapezium this
Uh,
way? Is it?
yes.
Yeah, this is a trapezium. So in that trapezium, I can say this is it's something like this way, this way, this way, and this way. Right? Probably it seems like this. Let me redraw that. So when there is a trapezium like this, so this is its base. Okay, this is that portion which is above it, and here is its smaller side, and here is its larger side, and this is its small size a. Okay, this is its larger side b, and this is the separation between these two, which was called as h. So what is the area of trapezium? Trapezium's area of the trapezium is a plus b times h divided by 2. Is it? Do you remember this thing?
Yes.
Yes. So a and b can be two speeds, but don't get uh, beyond this point, because a and b are two speed sides. A is basically its initial speed from 0. It is starting from 0, then its initial speed, then final speed, and then h. But simply you can say that it is equals to 1 by 2 a plus b times h. Or there is another method for this one. If you divide this triangle into two parts, sorry, if you divide this trapezium into two parts, you will get two segments. One of them would be your rectangle, and one of them would be triangle. Is it? For example, I have this graph. So in this graph, if I say that I'm going to split it into two parts, it is split it into two parts. So these two parts are actually this one. You see that?
Yes.
Yeah, this is a triangle, and this is a rectangle. Okay, so I can find area of rectangle plus area of triangle. In this way, I can find out the distance traveled by this object. So this was all about the how we handle the graphs in our kinematics. Is it clear?
Yes, sir.
Okay.
Sir,
Yes. Yeah, yeah. Any.
the uniform acceleration graph वो जो ऊपर नहीं था उसमें सर the formula v minus u ये was the change in velocity.
This one. ये वाला?
नहीं नहीं
Uh,
ऊपर ऊपर
ये वाला?
ये वाला ये बस हाफ इंटू v minus u है हाइट का वो नहीं होगा फॉर्मूला पूरा हो गया
हाँ हाँ, फॉर्मूला पूरा हो गया. बेसिकली ये जो हाइट है ना, दिस हाइट इज, ये देखो, दिस हाइट इज v माइनस u. बेसिकली
और फिर
आपका u
बेस
क्या था? u was 0 ना, है
जी
ना? Yes. So v was u was 0. So I can simply write it that s is equals to 1 by 2 v. ठीक है?
और फिर बेस एंड द बेस उसको भी तो मल्टीप्लाई करना है
Oh, yes, 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 yes. Very good. Well done. Into T. Into T. Very good. Good यार. So अब बात क्लियर हो गई.
Yes, sir.
ठीक. Yeah, yeah. Is it clear, बेटा? I
Yes, sir.
did not multiply this. Actually, I had multiplied till this point with t, but I forgot to multiply this t. So this is now multiplied with t. So usually this equation is 1 by 2 base times height. Okay.
Yes, sir.
Should I
Yes,
continue?
Yes, sir.
yes, sir.
Very good. Okay, good. Now, as I told you, that distance time and displacement time graphs, they have gradients, and their gradients are basically velocities and distances and all that stuff. So generally, if I talk about the graphs, the behavior of the graph is basically represented from the gradient. I will draw a general graph for distance and time, and then I will divide this into segments, and then I will let you know that during which segment which type of motion is being observed, right? For example, if you have this, this is time t is equals to 0, this is t1, let me call it t2, let me call it t3, and let me call it t4. So if the object is having this type of behavior, it means it has no change in distance. Let's say it is 10 meter, 20 meter, 30 meter, 40 meter, and 50 meter distance throughout. So for first 10 seconds, let me call it, it is 10 seconds, 20 seconds, 30 seconds, and 40 seconds time. So first 40 seconds object is not changing its position. It means, what can I say to this object? Isn't it at rest?
Yes.
Yes, the object is at rest. Then the object moves uh, from one point to another. So in this time, or from 10 to 20 second, the objects, I mean the distance time graph has constant gradient. Okay, what is the gradient of this graph?
Constantly
Constant
increasing.
positive gradient. Isn't it? What does it mean? If gradient is constant,
Doesn't change.
what about the speeds which is represented? Yeah, position is changed. So when position is changed, it means this object is having a constant speed, right? This object has a constant speed. When object has constant speed, its acceleration is equals to 0. Do you believe this thing?
Yes,
Clear?
Yes, sir.
yes,
Okay,
sir.
then let's have another motion till this point. Let me draw the segment. Okay, what do you think about this behavior from 20th to 32nd? It's, is its
Increase.
gradient increasing?
Yes,
So when distance time graph, its gradient is basically speed. So when its gradient increasing, can I say that it is it has an increase in speed?
yes,
Its gradient increases. So it is increasing gradient. So increasing
बस भगा जल्दी.
gradient. So when I have increasing gradient, it means speed increases. So
यू
speed
पूछिए
increases
भाई.
means,
there's acceleration.
yes, speed increases. So when there is an increase in speed, it is having acceleration. So it's, this is the acceleration graph. Am I right? Now, although this would basically interrupt this segment, like let's draw it. This one. Is it decreasing gradient?
Yes.
Yes. Decreasing gradient mean speed decreases?
Deceleration.
Yes. When speed decreases, so it is deceleration. That's very simple to understand. So behavior of the graph tells us very much about the motion, a description of the motion. So when we have this type of motion or this type of uh, behavior, for example, if I say these four graphs, these are four graphs now, 1 2 3 4, yes, these four graphs can be separately drawn: distance time, distance time, then distance time, then distance time, right? So if distance time is this, rest, uniform constant speed, accelerated motion, and deceleration. Am I right?
Yes, sir.
Will you remember this?
Yes.
Yes. So please remember these concepts, then we will practice the questions. Constant speed. So if constant speed, acceleration is 0, here acceleration, here deceleration. Okay. Now
Yes, sir.
let's talk about speed time graph. When you have a speed time graph can be considered as, let me divide this into segments. So each segment will be considered as a single graph, right? Okay, these all are graphs basically. So this is your speed time graph, this is your speed time graph, this is your speed and time graph, this is your speed and this is your time, this is your speed, this is your time, this is your speed, and this is your time. Okay, let's draw the first one. That is, if you have the speed time graph like this, if you have a speed time graph like this, if you have a speed time graph like this, if you have a speed time graph like this, if you have a speed time graph like this, if you have a speed time graph like this, so what do they show, right? So these are the maximum options which can be asked to you, right? These six, 1 2 3 4 5 6 graph. So what about this? Its speed is 0. This graph shows speed 0. It means body's at rest. Is
Yes.
it? So it means if I say this is your graph number 1, its speed time graph is over here, isn't it?
Yes.
Okay. So here in graph number 2, what is its description? It has a constant speed. It means its acceleration is 0. And I have shown you that graph over here. So this was your graph number 2, and its speed time equivalent is over here. Okay.
Okay.
Are you getting it?
Yes, sir.
This one.
Yes.
Okay. Now third is, this one is actually, it is increasing speed. Increasing speed. Right. It means acceleration.
This
Right.
is not constant
Actually it is uniform acceleration. This one is uniform
acceleration.
acceleration because its gradient is constant. It has constant gradient. Its gradient is constant. So you know speed time gradient is acceleration. So it has uniform acceleration. Okay,
Yes, sir.
got it? Okay, so let's say body A and body B. As I told you, the gradient is steepness as well. So A has greater acceleration than B. So acceleration of body A is greater than acceleration of body v. Am I right? Check this
Yes,
one
sir.
out. If a graph will have more steepness, it means its acceleration is more. Similarly, if I come to this point, I would explain it again. This one here, these two graphs are basically showing you the constant speed. They are, although they are distance time graphs, but here it is a, it is b. So if I say that it has constant speed, speed of a is v of a is greater than v of b. Do you agree?
Yes.
Yeah, yeah.
Yes, sir.
Okay, and it means this is your graph number 3, right? It is your graph number 3 from the top. And what about this one, fourth one? As I told you, sorry. It was graph number. Oh, sorry. It was graph number 3, and here it is graph number 3. Then I told you that this graph, it shows that velocity decreases, isn't it? Our speed decreases in this graph. Speed decreases. So when speed decreases, you know, uniform deceleration is there. What is there? Uniform deceleration, right?
Yes, sir.
Uniform deceleration. When there is uniform deceleration, I told you that this graph is similar as this one in your distance time graph, right? Because it is having uniform deceleration. Is it?
Yes.
Okay. Now these two graphs are the additional one because they were not in that displacement time graph. So here they are the additional ones. This one is having decreasing gradient. Decreasing gradient means its acceleration decreases, right? Its acceleration decreases. Okay, I will draw it in more precise way. This one, its acceleration decreases, and because its gradient decreases. Do you check that its steepness decreases all the times? Because what happens? Its gradient decreases. Am I right? So
Yeah.
when gradient
Yes.
decreases, finally at this point acceleration is equals to zero at this time. So in free fall, I was talking about that object would have a terminal velocity. Okay, object would have a terminal velocity. So I will explain it. Acceleration decreases to gradient decreases to zero. So terminal speed is obtained. Terminal speed is obtained. I will talk about that in the terminal speed concept. And what about this one? This one. It has increasing acceleration. Okay, increasing gradient as it is obvious, its gradient increases, so acceleration increases. Am I right?
Yes, sir.
Yes. So acceleration increases. So when acceleration increases, it means that the body is starting from minimum acceleration and then its acceleration increases and increases and increases and so on. Got it?
Yes, sir.
Yes. So these are basically all aspects of graph usually we have, and then finally we have the acceleration time graphs, right? In acceleration time graphs, usually this is your acceleration and this is your acceleration, this is your time, this is your time. So if I say this part, this is zero acceleration. So acceleration is zero, and then over here acceleration is uniform. Okay, this part shows uniform acceleration, right? So let me draw it in two segments. Again, this is an acceleration, okay, and time. And then we can have increasing acceleration and decreasing acceleration as well. In increasing acceleration, this is the graph, and then for decreasing acceleration, you can have this graph, this one. Okay, these are basically all about of this is all about your graphs. This is your increasing acceleration, increasing acceleration, and this one is your decreasing acceleration. Okay,
Okay.
Yes, sir.
right. So decreasing acceleration is not deceleration. Remember this thing. It is not deceleration. Deceleration is something like this.
In speed.
This one,
The deceleration is
yeah,
decreasing.
yeah. When deceleration will be there, actually your speed is to be decreased. So in deceleration time graph, uh, the graph should be below the axis.
Okay.
They all are deceleration time graphs. Actually, deceleration is your negative of acceleration. So this is your deceleration time graph. So I can say it is constant, sorry, uniform deceleration, uniform deceleration. Okay. Then we have increasing deceleration, and then I will draw a graph of decreasing deceleration. Okay. So here is, let's say, increasing deceleration, and then we have decreasing deceleration, right? It is increasing deceleration, and this is decreasing deceleration. Okay, so this is all about the graphs. I think it is much more detail at your level. So we can now talk about the past paper questions for a while. Okay, are
Okay.
you
Yes.
agreed?
Yes.
Yes.
Okay, so let me open up the assignment over here. Yes, this is your assignment, and in that assignment, I have some uh, kinematical graphs. Now we can handle all of the aspects, specifically this one. Okay, now let's talk about this. And yes, this one. Four balls in
Sir, screen.
balls. So sorry, screen is not yet shared.
No, sir.
Oh my god! When it was disappeared.
When you close the kinematics, वो जो पेज नहीं खोला हुआ था ब्लैक वाला,
हाँ 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 हाँ।
बस तब बंद हो गया.
बस उससे पहले ये आ रहा है, अब
आ रहा है
सही हो गया.
उससे पहले. यस.
ओके 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 ओके. अब देखो, four balls with different masses are dropped from the height as shown. Air resistance may be ignored. When you are going to ignore the air resistance, then what to do? Definitely there would be, they all will have uniform acceleration because they are under free fall, है ना? So when they are at the free fall, which ball has the smallest average speed? So the ball which is dropped from closer to the surface, it would have smallest average speed, right? Because in after 1 meter, its speed would be very small because it is dropped from very closer height. It takes more time because in A levels I will let you know that in first second, I mean first second of the motion, body covers 5 meters, right? So all of these bodies are having motion less than less than 1 second. But 5 meters, after 5 meters, speed becomes equal to 10 meter per second. So it means its speed is almost closer to 8 meter per second, almost 8 9 meters per second, right? Okay, or you can say 10 meter. This is less than that, this is less than that, this is less than that. So the smallest speed is of body A. Is it clear, though, clear to both of you?
Yes, sir.
Okay, then an an ice crystal falls vertically from the cloud. Okay, what happens to the acceleration of the ice crystal as it falls? This is what we have just discussed. In free fall, the objects falling down to the earth in air, they get air resistance, and definitely their acceleration decreases to zero. Acceleration decreases to zero,
Zero.
and finally they move with terminal speed. They get terminal speed. So here it decreases because because of air resistance. It decreases because of gravity. No, it increases. No, it does not increase. It does not increase. So its option is also option A. Okay.
Yes, sir.
Now this is a question. In this question, on Earth a ball is dropped. On Earth it means we are considering the resistance. A ball is dropped and falls 2.0 meter in vacuum. And the acceleration of the ball is 1 meter per second. 1 meter, sorry, the acceleration of the ball at 1 meter is 10 meter per second square. What is the acceleration of the ball at 0.5 meters? Yes. Any one of you?
Uh, 0.5 meters was 10 speed.
10?
Yes, answer is B.
Okay. Hassan, what's your choice?
Mm, A or B? 5 or 10 है.
5 or 10. Okay. Remember this thing. The ball, when I was talking about the free fall topic, in first few seconds, the ball has constant acceleration, right? Wherever you drop it, in first few seconds, game खेल रहे हो?
What?
Ball has constant acceleration. Okay,
Okay.
so when ball has constant acceleration, it at 0.5 seconds, its acceleration would be same as 0.1 second, same as 0.1.5 meters, same as 2 meters. Because I told you that in first 1 second, ball would travel 5 meters. So actually, this 0.5 meter is travel in very small interval of time. So its acceleration would be same as 0.10 meter per second square. Got it?
Yes, sir.
Yeah, Hassan.
Yes, sir.
Okay. Now let's talk about a graph question, then I will move to the next. In this question, a graph shows the distance, how the distance traveled by the vehicle changes with time. How the distance traveled by the vehicle is changed. Which row describes the speed of the vehicle in each section of the graph? This is what I was talking about. P, Q, QR, and RS. This is distance time graph. In graphs, the most important thing you have to see the label, what the y-axis is. So it is distance time graph. It means its gradient is speed. So you have to show between P, Q, QR, and RS what is happening. Between P and Q, what is happening? Yes, come on. Otherwise, it would be useless. All of that discussion.
Pure. In
What about the speed?
pure speed is constant.
Constant speed, because its gradient is constant. That's why speed is constant. Here, speed is zero because gradient is zero. Here again, speed is constant because gradient is constant. So constant, zero, constant means option A. Hassan, is it
Yes,
clear?
sir. Yes, sir.
And Yahya?
Yes, sir.
Okay. This was the question what we have discussed last time, but now I would talk about that in terms of today's discussion. This is a graph, and from that graph, I have to find out the acceleration of the ball. So in acceleration, actually, acceleration is what I told you, rise over run. So this is its rise, and this all is its run. So how much rise is? It is from 20 to 30. So you have written 20 minus 30 minus 20. And what is run? Run is basically x2 minus x1. It was 20. So your acceleration was 0.5 meter per second square. Got it?
Yes, sir.
Good.
Yes.
Okay. The last question, because I have another class ahead. A stone falls freely from top of a cliff. Top of a cliff falls freely. The air resistance may be ignored. No need to consider air resistance. Which graph shows how the acceleration of the stone varies with time? So which graph should be the your choice?
B.
B, sure, or delta? Bravo or delta?
Acceleration. Acceleration is same. It's t.
D. Hassan?
Yes, sir.
Acceleration is
Constant.
कांस्टेंट यस बिकॉज जब हम इसको ड्रॉप करेंगे तो एयर रेजिस्टेंस इज इग्नोर्ड तो all the times it would have same acceleration, right? When air resistance is ignored, acceleration is same all the times. So this is constant or uniform acceleration, so this would be right option. Okay,
Yes, sir.
right? So you have to keep on working on these graphs. See you in the next class, inshallah. But meanwhile, please do some work on the MCQs and theory. I have sent you these all. Okay?
Okay, sir.
Okay.
Yes,
Okay.
sir.
See you.
अगली क्लास सर ट्यूसडे को होगी.
I believe that yes, yes, Tuesday, Tuesday, Wednesday, and Thursday. Yes, the next class is at Tuesday. But meanwhile, you have to solve all theory and MCQs, and we will discuss the problematic areas on Tuesday. Okay?
Okay, sir.
Okay. Yeah, yeah, it's
अल्लाह
fine.
हाफिज.
Yes,
Allah
sir.
Hafiz. Allah Hafiz. See you. I will send you these notes. Don't worry.